Alright, welcome to our video on reliability. We're going to focus on some of the basic elements of reliability. Later on in the semester, we'll target item analysis. So even though we'll talk about some of the descriptive statistics here for items, our focus is not on the item analysis, but on reliability measures, such as the split half measure and alpha, and we can take a look at Hoyts and Nova as well. So to get us started, we just described their data set. We have 6 items, items 1 through 6. I'll go to the variable view, items 1 through 6 here as well. Subtest A is simply the odd items total. Subtest B is simply the total of the even items. And our total value is the total for each person across those 6 items. I'll go back to the data view. We can see under total, person number 2 got 1 of the 6 items correct. They scored a 1 total. Person number 4 got all items correct, all 1 through 6, and they got a 6 total. Subtest A, we can see that this is just the aggregation of odd numbers. So for example, person 2 got 1 odd number correct and none even numbers correct for subtest B. And you can go through this, pause it, or check out the data I sent to you on Blackboard and play with this yourself. The last 3 variables is just taking this data set and transforming it. I took all of these responses, 1 through 6, for all 10 people and stacked them here. I identified which item with this variable is item code and the person code here. So for example, person 1, item 1, their response was 0. Person 1, item 1, their response was 0. And I just stacked them all together. I'll use that later on. It'll get us started with a different conceptual work toward analysis of variance, and some of this will bring us toward the work we'll see as we'll look at reliability as in generalizability theory later on in another video, and in class. Let's go ahead and get started. I am going to start off by doing just a little bit of descriptive statistics. You might not start with this, although in your homework assignment I ask you for some of this. There's a lot of different ways to calculate out descriptive statistics in SPSS. For now, I'm just going to go to descriptives, select the descriptives dialog box, put the 6 items in as my variables, and under options I'm just going to specifically call and ask for the mean, and the standard deviation I could instead ask for the variance that we've calculated before, but remember the standard deviation is just the square root of the variance. So I'll go ahead and select continue and OK. And I have n, which is the number of people in each group, which is 10. I have the mean for each group. That's the difficulty, item difficulty. We've been starting to talk about the mean for each group. So we can see, for example, for item 3, the mean is 0.6. If you remember, descriptively, we added up all the ones, so there's 6 ones in this column, divide by the total, which is 10, and got 0.6. We get the standard deviation, which is the square root of our variance. All right, we can now go, and I'm going to go ahead and go and do a split half analysis for us under reliability. The dialog box comes up. This first time around, I'm going to just put them in the order they appear. I put all 6 items in. If you have 50 items or 20 items, you would just pop them in here, all the items you want to use in your analysis. I'm going to go under Model and select Split Half, but then I'm going to go to Statistics. We're going to use several of these later on. For now, I'm not going to ask for anything other than descriptives for the items. We'll come back and look at item scale if item is deleted later on and the F-test. I'm going to click Continue, and I'll go ahead and click OK. We get some descriptives. It's just an artifact of this data set. It excluded some cases. It's not actually excluding any of our cases. Just when I went through and created these variables here, we just have missing data, really, is what it's accounting for. these dots you see in SPSS, but it's really not missing data. They don't exist. So our alpha is reported. Really, SPSS just by default does a couple analyses, even though our main focus is the Spearman-Brown equate for equally length tests. It does the Cronbach's alpha, which we're going to come back to for each half. So part 1, half 1, part 2 is half 2. At the bottom, we can see where we have A and B. Items 1, 2, and 3 were used in the first test. Items 4, 5, and 6 were used in the second test. SPSS just split them in half in the order that we gave them. We had a total number of items to be 6. The correlation between the two forms is Form A, Part 1, and Form B, Part 2. Correlation is 0.820, and adjusting with the Spearman-Brown formula for 6 items instead of 3 gives us 0.901. That is one measure and one way to calculate out our analysis for the default for SPSS, which gives us values as 1, 2, and 3. But notice here in subtest A and B, I have this set up to give us a subgroups for odd and even data. Well, first let me go back into SPSS and under scale, there's several ways I could do this. I'm just going to show you a really easy way. I'm going to pull out the even values, and then so I have 1, 3, and 5 first, and now put 2, 4, and 6 next. I'll go ahead and unclick this item for descriptors. We don't need to see that again, at least not this time around. And now I'll go ahead and redo the split half. Notice within our adjustment that our values have changed. First, alpha levels are much higher within each group. We'll come back again to alpha, but remember alpha is every possible split half. So alpha here is a little bit weird in that it's all possible split halves within our split halves. So we're going to kind of ignore that for a moment. Our total number is 6, but this time when we look at the items used, the subtest 1 is using items 1, 3, and 5, and subtest 2 is using items 3, 4, and 6. The reason I show you this is to show you how important it is to pick the right subtest, or eventually to use Cronbach's alpha instead of the split half analysis. Our correlation between the forms in this case is now 0.342, much lower than the 0.8 we saw earlier. And our Spearman-Brown's prophecy formula, adjusting for back to a size of n, is only 0.51. So I'll just go back up. We can see previously we had 0.82 as the correlation between those forms and 0.901. So two things to mention from this is, one, the goal is to get you started with being able to conduct the Spearman-Brown formula, to be able to conduct reliability based on the Spearman-Brown formula and split halves. But two, also to tell you that it depends on the split half. The halves that you select, especially if it is truly one form that you're trying to do a split half analysis on, how they're selected matters unless we end up using a Cronbach's alpha. The Cronbach's alpha, as we discussed in class, is every possible split half. Every possible split half reliability kind of averaged out. So I'm going to go ahead under Analyze and under Scale Values and Reliability. I'm going to go ahead and select Alpha to start, and I will click OK. We can see we have a reliability for Cronbach's alpha slightly different, 0.804. This would be like if we went through and we took, for example, this split half analysis and this split half analysis and many other, all other possible split half analyses from this data and averaged them out. So we can kind of see that that 0.901 and that 0.51 for the split half Spearman-Brown coefficient of equal lengths, that those are, well, 0.51 might be relatively extreme and 0.9 might be relatively high. But if we were to take all of those possible split halves, it would average out to be 0.804, which is a reliability statistic we can use. So there's two different types of ways of conducting reliability. I'm going to go ahead and end this video for now because I think that's a lot for you to practice. But this is the basic introduction to the reliability. We'll talk about more, or already started talking about more in our previous lecture and in the class notes that we have online about reliability, what Cronbach's alpha is and what split half is. But now you should be able to practice and do the basic reliability analyses while you're at it.